Hello, everybody. So, last week we completed the module on risk management and analysis. And before that, we have actually completed the requirement management module as well, including different strategies and techniques that can be used to provide efficient management to requirements. In today's class in particular, we will focus on the last module in the requirement engineering process, which is requirement validation and verification. In this topic in particular, we will talk about what is a validation process for requirement, what is a verification process for requirements, and when there is a need to validate requirements and when there is a need to verify requirements, and mainly the different techniques and approaches that are widely used to verify and to validate requirements. So at this point, what we actually have done so far is after the fact, we did the elicitation, we did the analysis, we do have a specification document and text, like just textual information along with the modeling techniques. All of this information is just stored in a specification document. So along the way, we identified all the goals and the needs of stakeholders. We based on this we enlisted requirements and we did the analysis of those requirements, and then finally we do have the specification, the requirement specification. Moving forward from the specification, and then we have the SRS document, and then we're going to send it later to the developer team in the design phase at the end to have the developed system. There are some interconnections between those phases at which we do need to perform validation and verification. So verification is done when we move forward from the requirement specification, going to the design, and then going to the full development of the system, while the validation is a process that continuously are done from either defining our goals during the illustration phase or during the designing phase, or even at the final system deployment. So the question is, what is the difference between requirements validation and requirements verification? Requirement validation, so the question is, we like to validate requirements, means we need to answer the question about, are we actually building the right system? This is the question you need to find an answer for. Do our requirement specifications actually capture the real problem defined by the stakeholders? Did we account for the needs of all the stakeholders or not? That means we need to check the SRS document, again, is the stakeholder goals and requirements. This is validation. On the other hand, requirements verification is all about answering the question, are we building the system right or not? No, are we building, are we building the system right? Not the right system, but are we following the right procedure to build the system right or not? So the couple of questions we need to track it here to verify the set of requirements include, does our design actually meet the specification or not? Does our implementation to the system meet the specification in the specification document or not? Does the delivered system do what we said it should do or not? Are our requirement models, so we came up with the requirement models during the analysis phase, are those requirement models consistent with one another or not? If they are not consistent, so this can be detected during the verification phase. That means we need to check consistency of the SRS artifact and any other software development products, including design, implementation against the specifications that have been determined and provided during the specification analysis and specification phases. So for simplification, we can clearly say that requirement validation is all about ensuring that the software being developed or even changed will satisfy its stakeholders. So the criteria at which we will validate the requirements is by checking the software requirement specification against the goals of the stakeholders and the given set of requirements. On the other hand, for the verification, it's all about ensuring that each step forward in the process of building the software will actually yields to the right product. That means we have to check the consistency of all the software specification artifacts and other software development product, again, is the given specification. This is the main difference between verification and validation. So why do we need requirement verification and validation? Because it actually help ensure delivery of what the client wants. Also, it should be performed at every stage during the requirement process, starting from the elicitation, followed by the analysis, followed by the specification. So we are doing verification and validation not only during one phase in the requirement engineering process, but we do it at every stage in the requirement engineering process. In the elicitation, we need to check back with the elicitation sources. So we have, like, if you are doing elicitation, like you during an interview with the stakeholders, maybe a couple of the questions that you need to use it to verify and validate your assumptions is to say, oh, okay, Mister, are you saying this in particular? So just like confirm or rephrasing what the stakeholder just said. In the analysis, on the other hand, you need to check that the domain description and the requirements are correct. So you need, in order to build the correct model. In the specification, checking that the defined system requirement will meet the user requirements under the assumptions of the domain and environment. This is a big check that you need to do as a software engineer during the specification phase to guarantee that the verification and validation processes have been conducted clearly to guarantee that the specification document actually meets the requirement and the definition, the requirements and the definitions provided by the stakeholders. Also, you need to check the conformity to well-formed rules and standards, either by following the IEEE standard forms or by the enterprise standards. So during a verification and a validation phases, there is always a V and V criteria, where the first V is for validation and the second V is verification. So to come up with a validation and verification criteria, let's take an example that alternates between the application domain and the machine domain. In the application domain, I'm going to use the symbol D to refer to domain properties and R to refer to requirements. While in the machine domain, we're going to use C for computer and P for program. Some of the definitions that we need to define it here to actually came up with a definition for a V and V criteria. D refers to things in the application domain that are truly anyway, while R, which we said the requirements, these will be those things that are defined in the application domain that we wish to be made true. S, on the other hand, is a description of the behavior the program must have in order to meet the requirement. At this point, it's easy to extract different criteria for the verifications and for the validation based on the defined terms. So two main verification criteria can be extracted here. The first one, we could say the program running on a particular computer satisfies the specification. And the specification, given the domain properties, will satisfy the requirements. These are verifications requests or verification criteria. On the other hand, we can define some other validation criteria based on the alternation between application domain and a machine domain. We could simply say, do we discover and even understand all the important requirements? That's a validation question. Did we discover and even understand all the relevant domain properties? This is another validation criteria. So I can use the D variable here, I can use the R variable here, and then alternate between those terms and variables to come up or to extract some of the questions that could be used during the validation and verification. And then once we formulated those type of questions, we can easily do formal or informal verification and validation. Let's take an illustrative example to show the idea of verifying a couple of requirements or even verifying different domains. So in this example in particular, if I assume we have a requirement R, this requirement says reverse thrust shall only be enabled when the aircraft is moving on the runway. And then in the the set of domain properties, we set the wheels pulses should be on if and only if the wheels are turning. Also, another domain property, wheels turning if and only if moving on the runway. On the other hand, the specification could be reverse thrust enabled if and only if wheels pulses on. So the verification questions at this point that you need to extract could be, does the flight software, and then I'm going to use that P for it, running on the aircraft, I'm going to say C computer for it, correctly implemented the specification S or not? Another one, you could say that the specification in the context of the assumption of the domain, the, the, um, the domain properties, and even for the required satisfy the domain properties, the assumption of the domain properties are satisfy the requirement or not. That's another verification question. On the other hand, for validation, you could clearly say that our assumptions in the given in the domain properties about the domain correct? Did we actually miss it? Are the requirements are what like meeting like what actually really needed? Did we miss anything? These are validation questions, while these are verification questions. So defining the verification and validation, we need also to understand what are the main methods that can be used for validation and verification. In the literature, there are many methods. The main focus in today's class will be on prototyping, informal walkthrough, formal inspection and walkthrough, and even animation. These are some methods that are widely used for requirement validation. On the other hand, formal inspection, traceability, testing, model-based verification and validation techniques, including first-order logic behavior models, are also used for requirement verification. As you can see here, we have formal inspection, commonly used between to validate or to verify requirements. Now, let's start by the first component in today's class related to verification and validation, which is requirement validation. So, requirement validation could be done on two stages. It could be early validation or it could be late validation. Early validation, in which we will use informal walkthrough, while in late validation, we're going to use formal walkthrough and inspection. So for the informal walkthrough, to provide early validations to the requirements, أعمل فيك إيه؟ أنا أعمل فيك إيه؟